Hey, welcome to a series of 3 short videos on basic statistics in this course. And it's not going to cover a whole depth of statistics. It's going to assume a few things, and we'll try and cover those and have a look around the screen now. And particularly what I screen clipped from Google here, the statistics with a few key words there that you might already know. What do you know about statistics? Statistics is an area of mathematics where we are, let's pick this word in here, collection of data or collecting data, and that is collecting information about a group of objects or individuals, doesn't have to be people, and we're going to try and describe what that group is like, how tall they are or the colour of their hair, that sort of thing. So it's certainly about organising lots of data, stuff that we have measured, and then maybe interpretation of what's going on the average, how tall they are, how spread out their heights are or something like that. And later on, that's called descriptive statistics, that stuff. Later on, we're going to look at statistical inference, taking a sample of individuals and predicting what the population from which they came would be like. Inference, inferring what they're all like based on a few. So there's lots of statistical theory and stuff involved, but in this course we're going to do it fairly simply. So let's have a look around the screen for the moment, and if you come up to the top left hand corner here, let's have a look at this little graph, and I guess you've seen something like this before, where you plot some measurement along here, and the number of people, called the frequency, is plotted up there, or the number of items. Remember, what we're measuring does not necessarily have to be people. It could be the lifetime of motors made by a particular company, how they work out how long the guarantees should last for, and that sort of thing. We'll talk a bit about that later on. So this down here is the measurement. It says discrete data. You wouldn't usually put that there. You put the actual measurement. It could be the number of children in a family. 1, 2, 3 children, 4, 5, 6, 7, 8, 9, up to 9 children in the family, and how many families have that many children. So you have discrete or distinct values here. You can't have anything between. 1 in the family, 2 in the family, 3 in the family. So it's called discrete data, and that's our first word to try and get our head around the idea that the groups are different and distinct from each other. And you can't have anything in between the columns. You can't have 1.5 children in the family. What about over here? This looks like a different graph to me. And can you see why it's different? All the columns are up against each other here. Okay, so why would we do that? We're giving the idea that the data has no breaks in it. It is continuous from the English word. Continuous, no breaks, keeps going. So what could that be? What could we measure there? We could measure the heights of people. And we'll look at that a bit later on. So there's 2 different types of graphs here. One over here is called a column graph, just like it looks. And the other word we use is a histogram here, where it's a column graph with no gaps, if you like. And this indicates that the data is continuous, runs on, and any possible value between the measured values could be achieved. All right, let's look down the bottom now. Now, I've taken this out of a textbook, and they've been a bit naughty here because they've got distinct columns here. Can you see that? Distinct columns all the way. So that's sort of suggesting that this data is discrete, but then they've run a continuous line over the top of those columns, and that continuous line, of course, suggests that values in between are possible, values in between, and that would make it continuous. So very confusing. And why have the writers of that particular textbook done that? They're trying to give you some idea of the shape of the data. And can you see that this is nice and symmetric? Here you've got a heap which are higher than where the symmetry would be. So it's called positively skewed, if you like. It's skewed off. You haven't got symmetry. You've upset or skewed the symmetry. So here it would be symmetrical if it went like that. We've got this many too much, if you like. So here it is skewed negatively. And here it's got two peaks rather than one, and this is called bimodal. So we're going to have a look at that later on. I wonder if some of those things you've seen before, that would be handy. But don't worry if you haven't. We're going to really unpack it in this presentation. So what we'll do now is come on down and let's have a look at the next little bit and see what we can make out of that. Here we are. And so this is a little bit more detail of what I was just talking about there, that the shape of this graph is sort of indicated by the smooth curve, but it is a bit naughty to do that because you have gaps in between indicating that the data is discrete. So the smooth curve is actually in contrast to that and shouldn't be used there. But one thing that it does give you, it gives you a shape, an idea of the distribution to see whether it's nice and symmetrical, like this one appears to be, or whether it's got some on one end or the other that upset or skew that symmetry. So this is called a symmetric distribution. It's going to be pretty important in this little study on statistics. A symmetric distribution, and of course it has a middle, and you've got symmetry on either side. You've got the same number of scores, the same distance above and below the middle there. And we're going to be talking about how to find the middle of a distribution, all that sort of stuff. So can you see what we're doing? We're doing a little bit of descriptive statistics here, describing what's going on with a set of data or a set of measurements that we have collected. Okay, so statistics is the area of mathematics concerned with collection of data and describing and making inferences about things as a result. All right, come down now and let's have a look at some of the terms that in this course you're sort of expected to know. So we've done this first one here, data or data, information about the qualities or characteristics of a group of individuals. Please note that group of individuals does not have to be people. It could be heights of corn in a crop. It could be weights of sheep. It could be numbers of people in a family. So it doesn't have to be just people. It can be those, but it can be other items as well. A group of individuals of something or other, some type, not necessarily people. So now some of what you might have had in junior maths, a categorical variable is something we're measuring that fits into categories. What could that be? It could be eye colour or hair colour, that sort of thing. It's a category. It's not a number. Okay, so we're not going to be doing anything with that particular variable here much at all. What we're going to be doing is working with variables we can measure, and they're in number form. So that could be what? Discrete. It would be what? Number of children in a family, for a discrete example, or weights of sheep, something like that. Okay, so in continuous. Okay, so the numerical variables we're going to be talking about will fall into two categories. They've both got a numerical or a number value, but one is discrete, which is number of children or something like that, and the other one is continuous, weights of sheep. Okay, do you get it? One will be using a column graph and one will be using a histogram to show what data we've collected. Okay, now let's get on to something which is best summarized by this diagram here. Let's have a look at the diagram. We have a population, which is the total group that we're trying to look at. And then we're taking from it a sample only. We're not going to measure the whole population. Now, the whole population, let's look at that word, is the entire collection of individuals about which we want to draw conclusions. Okay. The census is when you go out and you actually take the whole population. Now you can see why that would be difficult, don't you? That's why we use a sample here, because the population could be huge, be too expensive to measure the whole population. When countries do measure their whole population of people, it's called a census. So they're trying to measure everybody. Sometimes that's not always possible. Let's skip down here and we go out and choose a sample at random to avoid bias. So in other words, at random means we're going to try to give everybody in the population an equal chance of being included. Otherwise it would be biased. So for example, if you're looking at who's going to win an election, you want to do the whole population, but you'll only do that at election time. So what do you do in the meantime? You go out and try to predict how people are going by taking samples over here. Taking samples and going to a range of different types of people, giving as many as possible the equal chance of being included. So you can predict what's going to happen here in the election. That's called statistical inference, and we'll be talking about that quite a bit later on. Let's have a look. What's a parameter? Is a numerical quantity measuring some aspect of the population. In other words, you've measured the whole population and you're going to draw a graph or something, and you're going to maybe do a measurement of what's the mean or the average or something. So a parameter is values calculated on the whole populations. Values on the whole population here. Okay, and that's called a parameter, a calculation based on the whole population. Okay, not always possible, so we're going to use a sample, we're going to do a survey and try to give people an equal chance of being included in that, and then we're going to calculate a statistic, a quantity calculated from data gathered from a sample usually used to estimate a population parameter. So it's too expensive to do this. So we're going to go and do a calculation based on the sample. So when you do a sample calculation, so it could be what is the average weight of the sheep, sample calculation, it's called a statistic. So it's only an estimate of what the population in total would be like. So you're trying to get some information about the total population from a sample. Okay. Next word we use quite a bit is distribution, and that's the pattern of variation of data which may be described as symmetrical, positively skewed. Can you see? There's a symmetry, and that's too much on that side. And here, to make that symmetrical, you'd like to go like that. So where's the excess? It's on the negative side of down the left of the independent axis there, down the bottom. So here we use those words. Skewed means the amount by which the symmetry of the distribution has been pushed to one side or skewed off symmetrical. Okay, so when you're looking for that, you're looking for the parts which are upsetting, if you like, the evenness or the symmetry of the distribution. And you can see it's nice if you use a smooth curve like that to get a bit of an idea of the shape. It's actually incorrect if you've got discrete data, but it does give you some idea, as I mentioned before. All right, outliers. You might have heard of this before. We're talking about these briefly later on. These are data values that are either much larger or much smaller than the general body of data. They should be included unless they are the result of a human or other known error. Okay, so if you say, oh gee, something went wrong there, I don't think that's possible, and we're going to try and find where the error has been made, then you would discount them if they can be assigned to some error. Otherwise, you've just got to deal with them and say, gee, they are different from all the others, they are special cases, but we have to look at and analyse the data with them included. All right, you're getting some idea. Come on down here and let's have a look at what we've already talked about, but just confirm it a bit now. A discrete numerical variable. Okay, we'll be talking about those a little. Takes an exact number values. In other words, they're single exact numbers, and usually are a result of counting. So in other words, this would be the number of children in a family, okay, along here. You wouldn't put this, you don't put that. That's just for the book's way of showing you the representation. So that could be the number of children, and you would put that along the axis there, number of children. And then you've got the number of families with that many children. So you've counted up how many families have got one child, two children, etc. All right, so you get the idea, and this is called a column graph, and we're doing basically descriptive statistics here, trying to describe what's going on with that particular variable. All right, what's another one? Continuous variable. Takes numerical values. Here we are. We're doing number measurements here, but it's got a continuous range. All values in between these columns are possible. So what could it be? Well, let's put a graph down here. It could be maybe heights of people in, I don't know, centimetres. Be 140, 145, 150, etc. along there. And you know, if you measure people and you can do it accurately, you'd have every height between 140 and 145. You might have somebody 144.95 if you could measure it accurately enough. Okay, so we're going to talk about how to draw those graphs, and this data is usually a result of measuring up here. You're measuring something, not counting up the number of children in a family, but you're measuring a continuous variable. So a continuous variable takes the whole continuous range of values from one end of the possibilities to the other. And the important thing is no gaps between them. This is called a histogram. Histogram is a column graph with no gaps, if you like, indicating a continuous variable. All right, come down now and let's have a look at the other thing we do. We draw graphs because people don't like to look at lots of numbers. They find lots of numbers confusing. So we can draw what's called a frequency table here. Draw up a frequency table. Here the value may be, this is discrete, isn't it? Separate numbers. Could be the number of children in a family. I don't know whether you have ever done this, but if you're counting them up, every time you get to 5, you put a cross across it. So this becomes easy to count up. So you're putting a stroke for every one, and then on the 5th stroke, a bundle of 5. So this would be 8, easy to count up. So every time you get to the 5th one, you put a line across it, and this would be easy to count up now. 1 bundle of 5 and a 4. You get the idea. Because if you did counting like this, tallying them up, if you were counting them up like this, it gets very confusing, doesn't it? To add them all up. So when you get to there, you put a line across. So you make bundles of 5. Okay, that's the idea there. All right, so you make up your frequency. This is the number of times that group was recorded, and then the total frequency is there. And then you could write the percentages that are in each group. What percentage had 3 children? So it's 6 out of 30. And as a percentage, that's a fraction times 100 is 20%. Okay, now there's your sample calculation from here. So these screen clippings this time are from Hayes Publications, and you should get their textbook to have a look at that. All right, so that's the idea of getting your data before you then try to draw the graph, perhaps. So that's called a frequency table for discrete data. Okay, come on down now and let's have a look. Here's one with lengths of something. And again, we've made some tallies here. So anything, the length is greater or equal to 9 but less than 10. So this goes up to 9.999. Once it hits 10, it's in the next group. So can you see that inequality sign? Okay, 10 is less than or equal to L is less than 11. So it can be 10 or more, but once it gets to 11, it's in the next group there. So study that, and we have the frequency in each group. Okay, and then the total here, which will be 30. So you could make a relative frequency for that as well. It could be 40 out of 30 times 100. You could do that for this one as well, depending on what you want people to see. If you wanted to give them an idea of how many of the lengths were between 12 and 13 centimeters, it would be 6 out of 30 times 100, or 20% again. So you could do those calculations for that type of table as well. So this is a grouped frequency table because you're grouping the data, and you have to do that, don't you, for continuous data, because you could get a length at 9.1, 9.2, 9.3. So very hard to represent that unless you do groupings for your histogram. All right, come down and let's have a look at examples, and that's about all we need to learn to do the examples in this particular section. So here we have 20 juvenile or baby lobsters randomly selected from a tank containing several hundred. Okay, so they've got several hundred there. And each lobster is measured in centimetres, and the results are those. So you can see there's lots of different decimal points here. It is continuous data. Now organise the data using a frequency table and hence graph it. So let's come down here. We can see it's continuous. They've been round off to the nearest millimetre there, 0.1 of a centimetre. The shortest length is 3.1, the longest 7.3. So you could start with from 3 to 4, 4 to 5, and you usually choose these lengths, the size of the group, so that there is between 5 and 10. Here there are 5 groups. It gives you an idea. And you choose convenient numbers, okay, ending in whole numbers there. Then you've got to count up all of those between 3 and 4. Now, they haven't shown you how to do this, but I'll give you an indication here. You don't go up and count each group separately. You read the first one, cross it off. 4.9, that's in that group, so you put a mark there. 5.6, that's in that group, so you put a mark there. 7.2, that's in that group, so you put a mark there. 6.7, it's back in this group here, so you put a mark there. You can see what we're doing, and then you total them all up, so you get these frequencies. Don't forget, when you get to a bundle of 5, you put a stroke across it. So the next one is like that. So it makes it easy to count them up. Okay, so now we want to do a graph of that. And the graph would start at 3 and go to 8 in groups of 1. We have to have this label here, and we've got a gap here because we want to start at 0 for this axis, but it's not starting at 0, so that means you have a gap there. This first gap does not represent 3 under the units you're using here, because 3 would have a big gap in between. So you squish that up a bit and you put that break in the scale there. Okay, so we've drawn our histogram. Each one is to the height that we have for the frequency of that group, and we've drawn a nice graph. No gaps between the columns. And then it says, what is the modal class? Well, I don't know whether you remember this. The modal class is the class that's got the biggest number in it. So the modal class is the tallest one, 6 there. Okay, so that is the class running between 4 and 5 centimetres. And just look at the way we represent that. 4 is less than or equal to L, less than 5. And that occurred most frequently, so that is the modal class. And the data is, well, we've got some pattern here, but really that's too heavy on the right-hand end, so it's positively skewed. So giving people a good description of what this group of lobsters is looking like. And later on, you might be able to say, well, we predict or infer that the whole population would look a bit like this. Okay, so we'll be doing a bit of that later on. We're describing what's going on with a sample here, and we're going to do more with that. Okay, come down, and it's your turn. So here we are. Here are some problems from Hayes, so you should have the textbook handy by. So I want you to pause the presentation, have a go at the problems, and then I'm going to show you the fully worked solutions at the end, further down the screen. So if you do a question, you can toggle forward, look at the answer, then come back. But don't look at the answers, the ones you haven't done. Okay, so pause it, have a go at those three. Let's look at the next few now. 4, 5, and I think we've got 6. No, we can't quite get in. So let's do 4 and 5. So pause the presentation and have a go. Question 6 and 7 we can get on there. Question 6 and 7. Okay, pause it, and now I'll show you the answers. So here are our answers down here. Question 1, 2 and 3. Let's go to question 4. 4 is a bit long, so there's question 4. 5, and we've got 6 at the bottom. We'll come back to that. 4 and 5. And we'll be able to do that part of 6. And then 7. Okay, so I hope you enjoyed all of that, because it's just a basic introduction now. So I will catch you up in the next presentation. Cheers for now.